So welcome everybody. Welcome again to another Go of our Go webinar. This is part number 8, and we have the pleasure to have Fuhrimann with us today. Tobias Fuhrimann, who will be giving us some tips on how to run Go web applications on Application Cloud and Cloud Foundry. And without further ado, I will give word to Toby.
Thanks a lot, Richard. So first of all, my sincere apologies to all of you for the troubles that we had last time. We had some technical difficulties in starting the GoToWebinar application, but now it seems to work. So let's get started. First, a little about me. I'm a web application developer at Swisscom. I've been doing a lot of Node.js, and lately I've been doing a lot of Go as well. And I've really come to enjoy writing web applications in Go because it's a lot of fun. First, let's delve quickly into the language itself. So many of you might be like, what the fuck is Go? Or some of you might already know it, but I'm going to give you a quick overview over what Go is and why I like it. So Go is a very young programming language, and it can be used very well for web applications, but also for system tasks. It's very fast, so it compiles to a binary, to machine code, and that's why it can be executed very fastly. Also, that makes it really portable, so it can be used on any kind of operating system, and you can even cross-compile. So if I'm on my Mac, then I can easily cross-compile for Linux or for Windows, and it will create an exe file that any Windows computer can run. And I think that's quite powerful. That also allows us to deploy Go apps to Cloud Foundry in different ways, which we will quickly look at later. Go is also a strongly typed language, which I've really come to love. So it really helps if you're developing it. You get nice suggestions or auto-completion suggestions by your IDE. And you always know whether your app will compile or not, because the Go compiler is really fast, so you can compile a lot. And you will always quickly get error messages. And if you do refactorings, then you will always quickly know whether your app still works or not and what you would need to change to make it work again. What I also really like about Go is that it's what I call batteries included. So it comes with a lot of powerful standard libraries, and it comes with a lot of tooling. Also, it's quite opinionated. So, for example, you have a formatting tool that comes with the language that allows you to format your files, and in that all the Go code that you will find online will pretty much look the same because it's all been formatted with this one formatter. So as I said, it's quite opinionated, but I for one like that because it makes it really easy to read Go code. You know that it will always look the same. And since the standard libraries that it comes with are so powerful, you will also be able to almost always do everything with the standard libraries. So you will not likely need to use any frameworks or anything else. So if you want to read somebody else's code, you only need to know how the standard libraries work, and you don't need to read into some complex libraries or frameworks that you would need to know. You can just read the standard library code and you will know what's happening. If you look online, there's a lot of things that have been built with Go. So for example, Docker has been built with Go, Kubernetes, part of Cloud Foundry itself as well. There's etcd, Console, Prometheus. There are really a lot of modern applications that are used all across the world and in many even enterprise-grade architectures and applications that have been built with Go. So it has very quickly become a quite popular language. I think it was created in 2011, and by now it's already a very popular language and it's being used a lot all over the world. Let's quickly look at the topics that I would like to look into today. First, I would like to look into how to build a simple CRUD API, just to give you, excuse me, to give you like a feeling of the language and show you how easy it is to build these simple CRUD APIs. Then we will see how you can deploy Go to Cloud Foundry. And then if we have time, I would like to go into some more advanced topics like writing HTTP middleware in Go, testing web applications in Go, and kind of the architecture that you would use for your folder structure of a Go web application, or at least the one that I have been using, because there Go is actually not that opinionated when it comes to these folder structures, so you really have a lot of freedom there. So let's start. Let's look at it. A very simple web application. Here you can see at the top, you define the package. Now this is package main. That's always if you create an executable or an app, that's going to be your package main. And then, as you know it from any other language, you have your import statements. Here I'm importing two packages from the standard library. That's why they're just called FUMD and NetHTTP. If I was to import any third-party libraries, then Go uses the namespacing that the version control systems provide. So if I imported any package directly from GitHub, then it would be import github.com/the name of the creator / the name of the project. So you can pretty much take part of your URL, and that's going to be your import statement. And that makes it really nice to read and easy to work with. Then the next line, so this down here, is the definition of a function. Here I'm defining an HTTP handler, which is then used in my main function. So maybe let's look at this one first. The main function is what's going to be executed when my binary executes. And it has a handle func statement here. This means please listen on the route /, so my index route. And if any request comes into that route, then I will handle it with my function called handler. And that's what's defined up here. Then the other statement underneath is HTTP listen and serve. So that creates a simple HTTP server, which will then use my handle functions that are defined up here to kind of create a web application. In my case, it's just listening on port 8080, so it's going to listen on localhost, so I can run it locally. And then the handler itself, there Go is also quite opinionated. For these handlers, you always have these two arguments, which is W, and that's of type response writer. So I can write my HTTP response to this object. And it's a request. As you can see here, this R is a request. And this little asterisk here means that R is not just a request object, but it's actually a pointer to a request. So down here, you can see that I can now read anything from this request. This fumd.printf will read a or will write a string to a writer, in this case, my response writer. And the string is then over here, so it takes this URL path from the URL. So actually what this little app is going to do, if you hit / and then any string, it will just say, I love this string. So quite simple, but I think it shows how powerful the standard libraries of the Go language are. Now, what if we wanted to deploy this very simple web application to Cloud Foundry? What would we need to do? That's actually also quite easy. We just need to add the part that you see printed in bold down here. So what you see here at the bottom is that I am getting the port from the environment. That's this os.getEnv. It gets the port number from the environment variable port that also Cloud Foundry is using to define which port an application should listen on. And then down here, I have my standard default that I fall back to if this port variable isn't set. And that makes it easy for me to still do local development. So if I do local development, I won't provide this port environment variable. And then the app is simply going to listen on port 8080. So that's what I'm used to when I develop Go applications. And as soon as I deploy to Cloud Foundry, this port variable is going to be set by Cloud Foundry, and the app is automatically going to listen on the correct port. That's quite standard for also any other programming language that you deploy to Cloud Foundry, but in Go, it's really just adding these three lines, and then down here making the port dynamic instead of listening on the hard-coded port 8080. Now, as I said, there are different ways of how to deploy your Go apps to Cloud Foundry. One is the official Go build pack. For that one, it's easy if you use some vendoring mechanism. So if you have third-party libraries, then there are tools that you can use to manage these dependencies that you have. And these are supported by the Go build pack. In this example, I'm using the glide tool. And there you can just say glide init to make the project that you are currently in a glide package or a glide project, sorry. And then with glide get, you can pull in dependencies. And these are then going to be saved in some glide.yaml file. So that's going to take care of all of your dependencies. And then when you use cf push with -p, so that stands -b, sorry, that stands for build pack, then use the Go build pack. Then it's going to automatically recognize that you are using glide to manage your dependencies, and it's going to use glide to install dependencies in Cloud Foundry. So you don't need to push the dependencies, which makes the pushing really lightweight. You usually just push a couple of kilobytes because you only have your actual source code files that you are pushing. And then this -m here, that sets the memory limit. And I set this to 64 megabytes here just for demonstration purposes, because I really want to emphasize that how efficient Go is. Usually the web applications that I write in Go, they use about, I don't know, maybe 5 to 10 megabytes of memory. So Go is really incredibly efficient, especially if you take into account how fast it is as a language. So that's kind of the standard way, using the Go build pack. But since I said Go also compiles to a binary, you can also use the binary build pack that Cloud Foundry provides, and that even is one of the standard build packs. And what you would need to do to use this build pack is to build your Go application on your machine. And that allows you to take care of all the vendoring and dependency management on your machine. And Cloud Foundry doesn't have to take care of that. So once you have all your dependencies installed and your library or your application is working, then you can simply execute the Go build command, which will create your binary, and then only push that binary to Cloud Foundry. What we usually need to do is to set these two environment variables, so the Go OS and the Go Arc. These make sure that the binary is compiled to, or the application is compiled to a binary that actually runs on Cloud Foundry. Because by default, if I compile the application on my MacBook, then it will compile it for a Darwin OS, so for Mac OS. And if I use these two environment variables, Go is going to cross-compile to a binary that actually runs in Cloud Foundry or on AMD64 Linux. This binary I can then push to Cloud Foundry, so there I would again use this -b flag to use the binary build pack. And as I said, the big advantage of this is that you have to, or you can manage all of your dependencies locally, which is a big plus in my opinion. The other option is just a little simpler, because then you can let Cloud Foundry take care of all the vendoring and all the third-party library management. And you can, the artifacts that you pushed are a little more lightweight because you don't need to push any dependencies. But it's going to take a little longer to push, because then Cloud Foundry has to get all the dependencies and do the compilation of your application. Okay, now let's put these words to use and create a small little CRUD API. And I promise you it's going to be terrific. Actually, it's going to be quite simple. So we're going to create an API that you can manage cute kittens with, like the one that you can see here. For that, I have prepared kind of a skeleton application, which just contains what we looked at before. So here, again, you can see the package definition, the import statements, and I already have the main function, which contains this dynamic reading of the port environment variable. So now what we're going to do, if we want to manage our kittens, is we're going to create this kitten. So we're going to define what a kitten looks like. And for that, I'm going to write here type kitten struct. And then I'm going to define what my kitten looks like. Now we're going to keep it simple. We're just going to have kittens with a name, and that's it. And then usually it's good if you also provide a comment that quickly describes what this kitten does. So you say kitten is a cute kitty. There we go. So now we have our kitten defined, and now we need to create our handlers that will then actually return these kittens to a user. So I'm going to define a function, find kittens handler, for example, and this one will return all the kittens that I have. So as I said before, this takes a response writer. And as you can see, that's what I meant with that I like how Go is really statically typed. You get these nice auto completions in pretty much any text editor that supports it, which is really, really helpful. And then it also takes this pointer to an HTTP request. And now I can say what I actually want to do or how I want to handle a request that's coming into this endpoint. So I'm gonna encode the JSON that I have, I'm gonna encode the kittens that I have into JSON. So let's just assume that we have a variable kittens, which just is an array of kittens. So I'm not going to use any database here, but you could imagine that this kittens variable would actually be the kittens that my database is holding. For this demonstration, I'm just going to hold them in memory because it's easier. So now here I'm going to encode these kittens in JSON so that I can return it from my API. For that, I can again use the standard library. So I'm going to use a new JSON encoder, which writes to my response writer. And then it encodes the kittens that I have. As you see, when I save, my editor automatically imports this encoding JSON package, which is also part of the standard library, and it's used to, as I said, to encode this JSON. Now, since we are good developers, we should always do error checking, and that is something that is quite specifically done in, or explicitly done in Go. So I know that this statement that I have here, this encode statement, it may return an error. So I'm gonna try to catch that error here. I'm gonna say if anything is returned, that's gonna be saved into this error variable. And then I can do something with that error variable. So usually if there is no error, this error variable is going to be nil. If there is an error, it's not going to be nil. So it's going to actually contain an error. And I can use this now to do some error checking. So I can say if my error is unequal to nil, so if it's not nil, then I will do something. For example, I can log this error. I can, yeah, and then I can just abort the handling of this endpoint. And usually, what's good to do is to also return the correct error code to the person who wants to, or who is requesting something. And for that, you have a nice little helper function, which is also part of the standard library of Go. So I'm writing an HTTP error to my response writer. I can give it a nice text, so maybe error encoding kittens, and I can give it the status code that I want to use, not 5,000 but 500. So this is just good practice to return these things. What's also good practice is to set the header the content type header to JSON, since we are actually returning JSON. And for that, I can also use the standard library, which takes care of that for me, where you can just set headers on this response writer. Then I can say I want to set the content type header, and I want it to be application JSON. Okay, so now I have my my handler ready, and now I just need to use it down here. And I would like to use this opportunity to show you one of my favorite libraries that I'm using, even though I said that it's always good to do stuff with the standard libraries, but there are these frameworks for Go that are more like a toolbox. So and Gorilla Mux is one of them. It's pretty much my favorite one for doing web applications, and it helps you to create really nice routers for your application, where you then have access to, for example, URL parameters, or you can say a certain handler should only handle a request if it contains a content type header. So, for example, or an accept header actually. So you can say if the requester wants JSON, then I use this handler. If they want XML, I use a different handler, and so on. And to use this library, this Gorilla Mux that I mentioned, all I have to do is create a router here. So as you see, I'm creating a new router and I'm assigning it to this variable R. But what's happening now? Oh, I see that Mux is not defined. That's because I haven't imported the Gorilla Mux package yet. So let's do that now. As I said before, I'm going to use Glide for that. So, oh, sorry, I'm in the wrong folder. There we go. So I can use Glide init to initialize this package or this application to be a Glide application. And then I can simply use Glide get, and then the syntax that I told you about before. So here we have the namespacing, github.com/gorilla, which is the user on GitHub, and /mux, which is the actual library. Now I'm importing that using Glide. It's going to ask me whether I want to support version ranges and so on. That just makes dependency management a little easier. Now, as you see, it created these two files, glide.log and glide.yaml. In glide.yaml, you explicitly define which dependencies you want to use. And in glide.log, it then really locks down the exact hash of the dependency that you are using, so that you're always sure that what works on your machine, it will also work wherever else your libraries or your application is being used. Now, if I save my file again, Go is automatically going to import this Gorilla Mux library, and my error is gone. Now I see a different error, but it now knows what I mean when I say Mux. Then down here, I can define my handle func as you have seen before, and I'm going to listen to the /kittens endpoint, and there I'm going to use my find kittens handler. What I can also do with Gorilla Mux, and what is really helpful, is I can restrict this to only listen to the get method, for example. So now this endpoint is only going to respond to if the requester uses the get HTTP verb. And now with Gorilla Mux, I need to replace the router or the multiplexer that my application is using down here. So before I had nil here, which is just the default one, and now I'm replacing this with R, which is my Gorilla Mux router up here. And that's it. So now we have a final application. It's not actually a CRUD application because it can just output something that's already there. But I think you get the gist. You know how easy it is to create the other endpoints now. And also, it would be quite easy to just replace this in-memory kittens object or array with an actual database that I would retrieve stuff from. What I've found out quite recently is that there's a really neat way of structuring your web applications in Go. And I'd like to show you that real quick. So this is the folder structure that I've been using lately. So you have your My Project, which is the folder that your project lives in. And then in there, you treat your project as a library. That's why it says library-based development at the top. So every function that you create, so for example, the handler that you saw before would be a function that is part of this library that you are creating. And then you have this CMD folder here where you have your main file, which then just consumes your library. And that makes it really easy to know the users of your library and to make your library independent of the user. So this main is just a sample user of my library, but anybody else could come in and use my library as well. This makes it easy to test it. So for example, I have this other test file here, and that will be a test for everything that is written in this other file. But the packages are going to be different. So in this other, I'm going to use package my project, and the other test would use a package my project underline test. This means that the tests are actually consuming the package or the library that I used or that I wrote as externals. So I can much better simulate how an actual user of my library would see it, and really test it from an external point of view, which I think makes it really more durable, the tests that I'm writing. Also, this main.go file here, which creates the actual binary, also consumes my library as an external. So I always get to use my own library from the point of view of somebody that would use it from an external point of view, which really forces me to structure my library well, to think about what do I want to export, what do I want to keep private, and so on. Since we only have 3 minutes left, I would say let's quickly look at the topic of HTTP middleware, and then I'm open to questions. So HTTP middleware, I think most of you know, but for those who don't, are things that wrap the core of your application like an onion. So if a request comes into your application, then you can add these middlewares that will then be able to do something to the request before it reaches your application or before it reaches the actual handler in your application. Some examples are you could log the request, you could transform it, you could, for example, check if it has all the correct headers, and if it doesn't, you can just drop the request. So it really gives you a good possibility of logging and sanitizing the request before it reaches your actual application. So you can do authorization, authentication, everything with HTTP middleware. And that ensures that you don't have to use or that you don't have to write these middlewares for every single of your endpoints, but you can write them once and then just apply them to all of your handlers. And we'll quickly see now how that can be done. So here at the bottom, you see I have an example middleware, which follows this type that I have defined up here. So a middleware is a function that takes an HTTP handler and returns an HTTP handler. So that means that I can chain my middleware however I want, because they will always return something that satisfies this HTTP handler interface. And so that ensures that my middleware can be used in any application as long as this application follows the standard HTTP handler interface. And that's again something where Go being opinionated comes in really handy, because then you can write these middlewares and you know that anybody who follows the standard library patterns will be able to use it. This is probably the most simple middleware. It's a logging middleware. So here I can just simply log the request. There's also this nice defer word or keyword in Go that allows you to execute something as soon as the surrounding function has ended. So here I can say I'm going to log when the request is coming in, and then just the first statement will execute as soon as the actual request has been handled. So I can also then, for example, track the time that it took for my request to get handled, and then log this at the end and stuff like that. And then down here, I'm going to call the next HTTP handler in the chain. And that makes it really easy to chain these handlers, because they will, as I said, as you see here, they will just wrap around each other like onions, or like an onion. Here is the function that will then be used to actually chain these middlewares. You don't really need that, because you can simply create the onion yourself. You can wrap function around function around function. This one just makes it a little nicer to read. So I created this chain function that takes an HTTP handler, which is the core of our onion, and it takes a various numbers of middlewares. So these 3 dots means that it can be any number of middleware. It can be 0, it can be 200 middlewares. And then what it does is it actually creates the onion in here. So it loops through these middlewares and just wraps them around each other. And then down here you can see how this can then be called. So I have, for example, my index handler in the middle. then I do the logging, then I add the user info to my request, maybe as a context. Then I check if the user is authorized. If they aren't, then I will just drop the request and so on. So since our time is already up, I won't have time to go into testing and frameworks, but I will upload my slides and then you will just be able to see that there. Because I would like to give you a short amount of time to ask questions if you have them.
And we have one question already. Can you see it in the GoToWebinar console?
No. If you could read it to me, that would be helpful.
Sure, I'll actually just paste it to you. It's second. And are you off Slack?
No, I can see it. So the question is about the HTTP error function, and it says that the person who asked the question understands that this error message would be shown in the browser, which is nice for development purposes, but for production systems that can be dangerous because you could leak potential information about your running system that you wouldn't want the user to know, because that would make it easier for your users to exploit your system. And that is very true. What I usually do is I create my own handle HTTP errors function. I can show you an example of that in one of my projects that I have. Let me quickly pull it up. Let's take this one, for example. So here you can see my example HTTP error function that I'm usually using. And as you see, it also takes a response writer that it will then write to. It takes a status code, an error, and some message. So here I differentiate between the actual error that I'm getting and the message that I'm leaking to the user. And then the function does some stuff if there is no error provided or if there is no message provided, but it makes sure that the error never reaches the actual customer, but only this message that I set will reach the customer. And in that way, I can make sure that my server to log, it gets all the information that I have. So it, as you can see here on the line that I'm currently at, it logs the actual error plus all the messages that I'm also giving to the user. But to the user, I'm only sending this message. As you can see here on this line, it then calls HTTP error with this external, what I call external message. And that is the part of the message that I want to leak out to the user, which doesn't contain any important information, but only contains as much information for the user to be able to know what they did wrong. And then to my server, I log the full error, so the full error message. And that is how you can come by this problem that the person in the question asked. Are there any other questions?
I don't see any further questions, but anyway, if anybody will have any, there is one question. No, that's the thanks for the answer. If anybody will have any further questions, please feel free to send it to richard.veloch@swisscom.com, and we will try to include the answers in the follow-up email. And the recording will also be available on our resources page. And I would like to thank everyone for your attention and for your time, and especially to Toby, who prepared the webinar and against all technical odds delivered value for us today. So thank you very much, everyone, and we wish you a happy afternoon.
Thanks, Richard, and thanks everybody for joining. Have a nice day.
Thank you.